All right, today we're going to start talking about probability, some basic fundamental ideas of probability. We deal with probability all the time. The question is, where does probability come from? Well, the history of probability comes from a gambler's dispute in 1654 that led to the creation of a mathematical theory of probability by two Frenchmen, French mathematicians Blaise Pascal and Pierre de Fermat. Antoine Gombard and Capulet de Marie, a French nobleman with an interest in gaming and gambling questions, called Pascal's attention to apparent contradictions concerning a popular dice game. The game consists of throwing a pair of dice 24 times. Problem was decided whether or not to bet even money on the occurrence of at least one double six during the 24 throws. A seemingly well-established gaming rule led de Marie to believe that betting on a double six in 24 throws would be profitable, but his own calculations indicated just the opposite. Hence, that discovered the idea of probability. People became interested in the science and mathematical probability. Now, I'll go right now to say, when we're dealing with probability, we're going to talk about dice, rolling dice. We're talking about card games that possibly could occur, possibly any sort of gambling ideas or playing of cards. Okay, I do not advocate for the idea of gambling, but it is a natural thing in regards to probability and to be able to deal with calculations of probability. When you get old enough, you do what you want to do with respect to gambling. So, I'm not advocating anything that you want or with respect to the gambling and gaming. But it concerns us all the time, because last night, as you sat there and saw the weather forecast, you sat there and you clicked on to the probability of a snow day calculator. And that gave you a probability of something occurring. Okay, weathermen deal with probabilities all the time. But once again, it's when we're dealing with probability, it goes back to a gaming idea, but it reflects back to everything that we deal with respect to the idea of weathermen, your insurance, as we talked about your car insurance. They're betting on you whether or not you're going to get into a car accident. Okay, how weathermen deal with probability. Weathermen deal with probability. We always look at the forecast. We have 40% chance of rain. Well, we'll call it snow here. Calling for a 40% chance of snow in northeast Ohio. How they determine the chance probability of snow is, if I can do a rough sketch. Of Ohio. And if we take a look at just the northeast Ohio, if they say there's a 40% chance of snow, how they determine the percent chance of snow is the amount of area that has snow at a particular time. Now, most weather systems will go from west to east. So if we just take a very general idea here and say, I'm going to look at 40% of this area here is in snow at some time. The systems will travel from west to east. So what will happen to this system is system will continue to travel from west to east. We'll still have 40% chance of snow, but that 40% will continue to change and shift as we go from west to east. Or if it's going from north to south. If we come here down to here. So they're looking at the amount of area that's going to be covered in snow at a particular time. And that's how they determine the percent chance of snow or rain. When we talk about a probability experiment, and we dealt with some basic probability, and we'll start out with that, but we'll continue to advance ourselves. It's a chance process. It's a chance process that leads to well-defined results called outcomes. Okay? So when you talk about probability experiment, some experiment, we can roll a die, and when I roll a die, I get exact outcomes. I can flip a coin. I can get exact outcomes. Okay, so we're looking at exact outcomes in a probability experiment. When we look at the idea of an outcome, it's a result of a single trial of a probability experiment. That's an outcome. If I have a die, what's the probability of rolling a 5? What's the probability of rolling a 3? What's the probability of rolling an even number? Okay, I have an exact outcome that I want to come up with. Okay, if I'm playing trouble, what's the probability of me getting a 1 or a 2 so I can get out and get started on trouble? Sample space. We look at a sample space. It's a set of all possible outcomes in a probability experiment. What's the set of all possible outcomes of a probability experiment? This is called a sample space. So if I'm tossing a coin, my sample space is, well, what's my 2 possible outcomes? Well, we can either have a head or a tail. And typically, we'll get a set, we'll put set braces around that. Say we have a set of values, a set of sample spaces, a set of values, so we have heads and tails. If I'm rolling a die, what's the problem? What am I going to get when I roll a die? Well, my sample space would be, I can either get a 1, a 2, a 3, a 4, a 5, or a 6. I'm just rolling one die, so I'm going to get one of those values. What's the sample space for children? For a family with 2 children. Well, if I take a look at my sample space, we can have a male and a male. We can have a female and a female. We can have a boy and a girl, so we can have a male or a female. But if we take a look at this, we have to also disseminate between, we have another possibility. And that other possibility would be the female could come first, the male could come second. So we have 4 chances, 4 different sample space probabilities for children or a family with 2 children. What would be the sample space of tossing one coin 3 times? Well, sometimes it's useful to use what's called a tree diagram, to be able to calculate possibilities of a sample space. And if we take a look at the tree diagram here, if I toss the coin, I'm either going to get a head or a tail. My second toss. Well, the first one is a head. I could get either a head or a tail with the second one. The first one is a tail. I could still get a head or a tail with my second toss. Then my third toss, I could get head or tail for each one of these. What this allows us to do is this allows us to be able to slow things down a little bit. And just go, okay, I can have a head, and a head across the top. Or I can have a head, and then a tail. Or we can go a head, a tail, and then back to head. Or a head, tail, and then tail. Then going along the bottom, my bottom scenarios, we could have a tail, a head, a tail, a head, a tail, a tail, tail, head, and then a tail, tail, tail. So in my sample space, if I'm just tossing a coin 3 times, I'm going to get one of these scenarios. I have 8 possibilities in regards to my probability outcomes. When I talk about an event as a result of a probability experiment, what is your event? It's a result of a probability experiment. We can have a simple event, which is one single outcome. If I'm rolling a die, I just roll a 5, or I roll a 6, or I roll a 3. Or we can have what is called a compound event, which are combinations of a bunch of single events where I can roll an even number on a die, which is I can roll 2, 4, or 6. When we deal with classical probabilities, your solutions can be a percent, a decimal, or a fraction that illustrates a likelihood for an event to occur. I will accept solutions as a percent, a decimal, or fraction. Does not matter. But with this, each event in classical probability, each event will likely be able to occur. If I'm rolling a die, I can roll a 1 through 6, and each one is equally likely to occur. And how we calculate probability is number of favorable outcomes of an event. What you want. What do you want to occur? How many chances what do you want to occur? How many chances or probabilities are there, possibilities there are, over total number of possible outcomes for the event. So if you're trying to roll a 5, probability of rolling a 5? Well, there is only one 5, which is your favorable, what you want, over a total of 6 possible outcomes. Okay, so you have favorable over total number of outcomes. We will stop there today. Tomorrow on Friday, we will pick up from there and finish off the notes on probability. You have no homework for tonight, but again, just do some of the preliminary stuff to begin with. So we will stop there today. No homework for tonight. Have a good day.